want to solve the linear congruence. 365x congruent to 15 mod 1205. Let's see if a solution exists. So let's find GCD of 365 and 1205. That's going to equal 5. And 5 divides 15, so that means there's a solution. So I can divide everything by 5 now. So 365 divided by 5 is 73. And that's going to go into 3 mod 241. So now I'm going to have to use Euclidean algorithm. So we have 241 is 73 times 3 plus 22. And then 73 is 22 times 3 plus 7. And 22 is 7 times 3 plus 1. And then 7 is 1 times 7 plus 0. So now we're going to work backwards. And so we start with 1. 1 is 22 minus 7 times 3. And 7 is 73 minus 22 times 3. So we have 1 copy of 22. 3 times 3 is 9. 9 copies of 22. So that's going to be a total of 10 copies of 22. And 3 copies of 73. And then we'll replace 22 with 241 minus 73 times 3. So we have 10 copies of 241. And then 3 times 10 is 30 copies of 73, and another 3 is going to be 33 copies of 73. And so to find the multiplicative inverse of 73, we look over here. So I'm actually going to rewrite this as plus 73 times negative 33. So the multiplicative inverse of 73 will just be negative 33. So what that means is 73 times negative 33 is congruent to 1 mod 241. So now I need to solve for 73x congruent to 3 mod 241. So I'm going to multiply both sides by the multiplicative inverse, which is negative 33. So this is going to be x congruent to negative 99 mod 241. This is negative, so I'm just going to add another 241 to that. So that's going to give me 142 mod 241. So the first answer is going to be 142. So actually the form is going to be 142 plus 241n, where n is an integer. Recall the original question was 365x congruent to 15 mod 1205. So basically we want to find x values so that it's between 0 and 1205, or 1204 rather. So we plug in n equals 0, you get 142, n equals 1, that's 383, n equals 2 is 624, n equals 3 is 865, n equals 4 is 1106. Now if we plug anything else, it's going to be bigger than 1205, so we're just going to end it there. And that is our answer.